This is a presentation of SBE 15, New York City.
Ladies and gentlemen, Mr. Rich Redmond from Broadcast Electronics. So the floor is yours.
Well, thanks a lot. Can everyone on the stream hear me with the mic here?
Very well. Nice.
Okay.
Mhm.
I don't know if I'm using proper mic technique or not, but I'm sure you'll critique me if you need to.
No, I'm noticing more of the gray hair. It must be that gig you've
Hey,
had
well, you
for
know
the
what's
past
the
year.
camera? I think this camera is defective. And if I'm also not mistaken, I'm certain it must be adding pounds because that certainly can't be me. Well, thanks everyone for the opportunity to participate. My name's Rich Redmond. Much like you, I kind of came up working on the technical side in radio and TV stations, starting in upstate New York and working for a company called Northeast Broadcast Labs. Spent time at Harris and Gates Air and at Broadcast Electronics. Occasionally, I knew which side of the soldering end to pick up without burning my hand. And there was even a time at Harris, we did a lot of studio systems integration. So I had the good fortune to build a number of facilities here in the city, including some nice studios for WABC and PLJ over at Two Penn Plaza. So it's great to be back. Colleague of mine, Mr. Joe Myers, is here. So Joe manages the Northeast region for BE. And so you'll probably be seeing him around. But anyway, so tonight we're going to talk a little bit about some new solid state FM transmitters. And then I also threw in a little bit of information on metadata management. You know, there's some things I'll mention as reviews. So Broadcast Electronics, many of you have known, based in Quincy, Illinois. We've been building radio and TV transmitters, mostly radio for a long time, more recently TV. And then, you know, a long time ago, it was things like consoles and cart machines. And for a long time now, we have an automated playout system called Audio Vault. In fact, we were just up at WFUV. They're putting in new Audio Vault 11 system. The group, Elenos Group, owns Broadcast Electronics. And so we have a couple of other companies based in Europe. Elenos is building radio transmitters, generally compact radio transmitters. The telco is a longtime TV manufacturer, and Pro Television builds digital modulators. So both for HD radio and for television as well. So, you know, BE product line, like I mentioned, AM, FM, and now TV transmitters made in Quincy, Illinois, and Audio Vault and other software products. We have News Boss, a product called the Radio Experience for data management. And then we've had some good success here in the U.S. with the compact Elenos line of radio transmitters. So everything from about 20 watts up to 30 kilowatts in in more of a compact type architecture. And then TV transmitters, both air and liquid cooled, from 1 watt to 50 kilowatts. So really a pretty broad set of type of transmitters. So the product we're going to talk about today is one we've called Quick Block. But before we really talk about the product, I kind of want to talk about transmitters in general, because over probably the past 30 years, as we've migrated from tube transmitters, solid state transmitters have kind of gone in two directions. Either there's a compact transmitter, you almost think of it as a big exciter. At some point, FM exciters were 10 or 20 watts, and now you might get a box that has the exciter in it, but it may have 1 or 2 or 3 or 5 or 10 kilowatts worth of amplification all in the same box. So that's kind of this mode of compact transmitters. And then there are modular transmitters. So these tended to be bigger transmitters. You may have hot pluggable power supplies, hot pluggable RF amplifiers. For sure, there's an exciter. It might be a module or a 2RU box. And each of them have benefits. The compact transmitters generally are pretty efficient. They fit in a small space. They're cost effective, operate with pretty good efficiency. But, you know, there are some drawbacks of them. And the modular transmitters, well, the great news is it's easy to swap out parts. And if you have soft failure because of one little piece fails, you're still going, but at reduced power. There's a number of other points. But generally, when we looked at Quick Block, we tried to say, what are the good things that our small transmitters are great for? And what are the things that modular transmitters are great for, and try to merge them together. So you have redundancy, you have ease of repair, you have the ability to stay on the air at high power levels when you lose a module or a part of the system. But still, you didn't want to give up things like small footprint. You know, probably all of us can remember, you know, there was a time when a radio transmitter site held one station and maybe you had a main and a backup transmitter. Now, you know, you have rooms with 2 or 3 different stations, main and backup gear in it. More and more stuff goes in smaller spaces. And part of that's because of cost, right? It's like you're paying for every square inch that you're renting. So if you have a bigger floor print requirement, it drives up the cost. So when we went down the path to develop the new transmitter, we tried to take the things that were not so great and move them outside. So, you know, what we ended up with was, you know, trying to get rid of things like single point of failure, trying to have making repairs requiring you to take the unit off the air, trying to get rid of things like you know, a limited amount of footprint and things that would impact your cost, like shipping back a module. In some cases, you know, you have to be a weightlifter to go take a transmitter module, put it in a big box and send it back. The idea was to make things small and easy to use that you could send in a FedEx box almost anywhere. So at NAB, we launched a product called Quick Block. The idea being that it's simply a case of building blocks that allow you to get to high power levels, but that you use the same fundamental pieces from a couple hundred watts up to 50 kilowatts. And so the point is that it's modular, but modular not just in the sense that you can pull out modules, but as we'll step through this, modular in the sense that maybe I started at a 10 kilowatt transmitter and then I needed to upgrade power. The combiners are modular, so you could add, the frames are modular. So everything is a combination of the same pieces, a little bit like a, you know, a building block kind of scenario. So what we'll talk about in Quick Block is it's really a series of modules, amplifiers, and we'll show you what's in there. But the idea is that we take these blocks, you can easily combine them either in a 3RU shelf or multiple 3RU shelves to get to different power levels. But that these are fully scalable. So one of the things that's kind of interesting is we stack up in the architecture, all the systems scale with the amplifiers. So through this transmitter, there are really just 2 types of blocks in them. The one on the right, and we'll go to an exploded view on that, is an amplifier module, which contains power supplies, cooling, amplifier, Viswar protection, and so forth. And the one on the left is kind of the control and exciter module. So pretty straightforward. There aren't, hey, this is the module we use for 5 kilowatt transmitters, and this is the module we use in 20 kilowatt transmitters. The architecture really gets it so that if I have a 1 kilowatt station in my network, I have the same pieces. So you can kind of look inside. Power supplies built into the bottom, fan cooling on the front, amplifier and control at the top, low pass filter at the module level. Well, I guess the music's cool. It seemed like it might be a bit much. So anyway, the point simply is that as we take a look at this, the idea is to make it so I don't have subsections of the transmitter all the way through the chassis. Everything's included in the module. So when I go to this, the amplifier module, very small, it's about 3.5 inches wide, 5 inches tall, fits in a 3RU chassis, and I'll show you an exploded view on the parts that are in there. But from a simplistic operation, from the front, there's a multi-status LED, so I can immediately tell not only is there an alarm, it's not simply red light, green light. I get a few other colors that can tell me what some of the general directions of issues are. So if I'm running a transmitter with 20 modules in it, I can easily pick out where and what type of situation there might be on that module. The controller, you can look at each of them and get more information, of course. So here's a bit more of a static display that I was talking about. But if we look at it from the very front, the number one, so there's a extruded cover. Now, while, yeah, it is kind of stylish and looks cool, the cooling mechanism is designed right from the beginning. So the fins on here are actually like the leading edge on an aircraft wing, and they're designed to actually guide the airflow so it flows evenly through the module, because they're all kind of angled a little bit. And the fan, accessible for easy repair. It's got a little umbilical that plugs in. You take the 4 screws out and you can pretty quickly change the fan. On the bottom is switch mode power supply. So this is one that the company's been building for some time. So it is repairable. It's not a, you know, off the shelf, this brand or that brand supply, along with the heat sinks. The top plane, so when we jump up to kind of number 4, we've got a little bit of control circuits in there that provide protection for the power control. So there's some RF drive and some smarts that help with VisWire foldback. We go into a single amplifier using LD-MOS devices today. And then you can see the thing that's blue with some like Swiss cheese holes in it is actually a clamp. So not only does it make sure that the device has got even pressure to get to the heat sink, which is under that. So in this case, the heat sink has been removed from the drawing, so it's easier to see everything. But also it provides some surface area for heat to be extracted out of the top. And then the devices at the back in number 7 are the low pass filters. So one of the things that we found is, you know, think back to tube transmitters, right? You always had this kind of big section that went at the output that was the low pass filter. And then solid state transmitters, you tried to pack them inside. Well, that creates a single point of failure. So if you have any issue in the harmonics, there's only one thing that can filter it out. So we can actually create much better filtering by doing it at the module level, so that as you stack up the transmitters, you don't have to have a 5 kilowatt low pass filter, a 10 kilowatt low pass filter, a 30 kilowatt low pass filter. They're all the same, and it's done right at the module level. So not only do you get better suppression, you actually have less loss because you're not sending nearly as much power through, so you don't dissipate as much heat. And what's the enemy of electronics? Generally, it's heat. So we keep the thermals managed quite nicely. And then the output of every module, each module does around 1.5 kilowatts, is a machine blind mate, like 7/8 UHF connector at the back that plugs into the combiner. So those are the parts inside each module. The controller module, or the CCU, ends up holding, in the most compact versions, a controller, redundant exciters, redundant power supplies, and dual driver amplifiers, all inside this totally removable module. So not only are there slots that you can open up to take the different modulator and controller card out, the whole module is replaceable. So if you think about it, in a lot of transmitters, the main transmitter controller is a board tucked inside that might be on a sidewall or a door. This makes it so it's a little bit easier to move that forward and make it replaceable. And it's got dual cooling fans at the back. So there's not very much heat in here because there's about 5 watts of drive is all that comes out of that device. So when we talk about the CCU, command and control unit, it includes the exciter, the controller, and an intermediate power amplifier. Again, we've got the same multicolor LED on the front. So if there's a fault, you get a quick idea of where it's at. And then we have kind of a iPhone type touch screen on the front that can go through different pages of, this one happens to be looking at the audio inputs. So we're seeing left and right, MPX, aux, modulation level. And so there's automatic switching in there for failover and so forth. And then you can page through other things with the different voltages. But again, same size, 3.5 by 5 inches. pretty compact. Now here's a static exploded view. You can see number one's the front door that I was mentioning. It tilts open and that's got the touch screen on it. Number four is a controller. And really, because there's control in each of the amplifiers for protection, it's more kind of like an arbitrator and transmitter level controller, meaning that it brings up information, it presents the web pages, and provides some high level control, but the transmitter can operate without that at safe power levels that the modules manage. 3A and B, those can be dual exciter cards. And then we have the dual power supplies in 6A and B. And then when we get into number 5 is actually 1+1 drive amplifier. So we have redundancy there. And then 7, we have dual fans at the back. So the goal was to not have really any single points of failure, the best you could make it. And then also make it so everything was hot pluggable and easy to swap out. So it's not like, you know, you need to stand on your hand to go get some mid plane out of the middle of the transmitter. Pretty modular.
Rich,
Yeah, bud.
is that module containing memory and all of the settings for the whole transmitter at that point?
Yeah, so there's some non-volatile memory in there. Now there are some of the protections, Bud, when I mentioned like at the module level, the fast VisWire protection and over temp and all that, that gets managed in the module. So it's not like if you make a controller change that you somehow need to sit down and program each of the modules again. But things like the APC control and whatever you set the, you know, if it's a 5 kilowatt transmitter, you're running at 3.5, that memory is in there. So if you change the controller card, you'd have to, you know, do a quick recal. But yes, that's where the memories are. Is that what your question was, Bud? Did I understand that right?
You did, and let's say that module fails for whatever reason, because things happen.
Yeah.
And let's say you have a spare, and let's say you program that spare that's on the shelf. I presume that it could sit on the shelf and then all of a sudden get plugged in and come to life.
Yeah, and you would be back going. So if that fails, what it's set up to do is assuming you don't have you're not in a fault condition, meaning like I don't have an iced antenna. If I'm running it at 3.5 kilowatts or whatever, if I lack the controller card, if there's a problem with number 4, each of the modules has power control and has VisWire protection and so forth. So that can keep going at the last set power. And then when you know, if you do have to change the controller card, the transmitter is running until you have a chance to change it. Now, if you do program your stuff in there, it should swap over pretty quickly. But if I'm not mistaken, you know, there is kind of you hit the button to turn it back on, because I don't believe, I think the front panel, when you pull that controller card out, needs a quick reset. But basically, it's all pretty quick. But well, it's not all that complex.
And there is, did I see on the meter, you have discrete audio on there too?
Yeah, so the input can be composite or left or right or AES. So the meter, there's a couple of inputs on there, and there's some input switching. So, you know, if you had composite coming from an Optimod or an Omnia or something, and you had, you know, backup audio coming in, you could use, there's a kind of simple audio processor that's in there that gives you, you know, some basic audio processing. It's, I guess if you were in a not super competitive market, it might be okay to be your main processor, but it's really more designed to be a backup.
So it's not a CRL inside?
No. I mean, I suppose you could dink with it and make it sound poor like that, but which for anyone who's been around 100 years ago, CRL is, a friend of mine told me, was for cymbals really low because it didn't have very much high end. So yeah, if you look on the left, Bud, you can see those are the meters for the input, the left, the right, the MPX input or composite, you know, an aux input, and then the modulation level. And then the menus are kind of, you know, finger specific size where you can jump to the different sections and, you know, either set a power or you can make some adjustments. You see the 3-band on the fourth tile over on the right. There's just some basic adjustments on the 3-band processor. So, you know, I guess whoever set this up thought the high end needed to be really shrill, but or I don't know, maybe they have too much bass. But anyway, yeah, it's a pretty simple, you know, tri-band processor. So I guess if I was guessing, it would probably be, you know, in an 8100 kind of ballpark, you know, something of that ilk. It's not a, you know, hot rod processor by any stretch of the imagination. And then you can see the other tile at far right, the fifth one. That's just showing some of the faults, where it can say if that's showing some over temperature and a timestamp and so forth. Now there's a full browser that goes with this. So, you know, most of the time we're looking at these things remotely. We're not standing in front of them. But the browser and SNMP. Here's a simple block diagram. So when I talk about these frames hold, if the exciter module is in the frame, so up to a 3RU box, we do 5 kilowatts. There's 4 modules. This was in a little bit earlier drawing, said 1.3. They're closer to about 1.5 kilowatt, a 1.6 peak. But anyway, you can see on the left dual exciters, which then go into a switch over to drive dual drivers that then can get split to the splitter and go to up to 4 PAs in the all-in-one, or 5 if you're building. So if you're building beyond 10 kilowatts, then we use full racks of 5 PA modules. So 5 PA modules for every 3 RU. And then we use a kind of standalone controller with a little bit bigger display on it and you know, typical 2RU exciters. But going left to right, you know, each RF module has both control in there, RF protection, forward and reflective measurements, the actual amplifier, the power supply, the low pass filter, and then we go into a combiner, and the output combiner then feeds the output connection of that particular chassis. And so if we have more chassis, we keep stacking. Like I said, there's really only a couple modules. You keep stacking them up. So if you need a 10 module transmitter, it's 2 of these 3RU chassis that stack up. And if it's a 15 module transmitter, there's 3 rows. So to the left is the block diagram of we call it a QB4 because it's 4 modules. And it has the 4 amplifier modules, does 5 kilowatts, and then has the control and exciter. The QB9 does a little over 10 kilowatts. And then we stack these up in a rack with frames of 5 PA modules across and a 3.5, a 3RU frame. And then there's a combiner and splitter in the back. And I think I got some pictures to show that. So we can do up to 50 modules in a single 19-inch rack. So pretty dense, pretty power dense. And frankly, you know, it's more for HD radio operation that you need that much amplification, not that you're really running, you know, 50 kilowatts for an average station. So here's an exploded view of the frame. The modules are what we just talked about. You can see to the back, I think number 4 is pointing at it. So this is the combiner. So the combiner and reject loads. So those are the machined blind mate 7/8 inch EIA connectors that go into the combiner. Combiner's in a machine chassis on the heat sink. So there are no cable combiners here. You know, some products have cable combiners, which are easy because you can take the precise lengths you need to combine and you can kind of coil them up or make them fit in a small place. But over time, you know, we've all had transmitters with cables, right? After a while, they kind of dry and sometimes crack. So these are all laid out and machined inside the aluminum box. The back of the frame, this one shows one that has the audio inputs. You can kind of see the number 5 points to the back. The primary AC connection comes in there. And then number 7 is the control board that's in the frame. So Bud, when you were asking about control, there's some that lives in each module, and then there's a communication port on each frame so that if you're talking to the outside world, you know, that's where you might make connections for either parallel or SNMP or other logic, or if you're taking multiples of these frames, that's how they communicate to the display unit.
So with it being
Yeah.
modular,
Uh-huh.
say for some reason, like you have a lower power or lower licensed power for a station, but then you're working on, increasing power range. Are you able to take existing frames and add in more modules to get it to the proper powers?
Yeah, so yeah, it's a great question. So it comes down to the combiners. So in this case, like number 4 here shows you a 4-way combiner, and you can kind of see there's a little blocking brownish color against the kind of purple. That's because the same size box can take a 5-way combiner. So there's 2 ways to get there. I just press the button and turn the power up is maybe I'm running 2 kilowatts today, but I think I'm gonna need 4.5. So maybe I buy a 5 kilowatt and I just run it a little bit lower and I raise the power. But more practically, when you get to higher powers, you could have 2 or 3 of these chassis and maybe be a 15 and you get a power increase. You can add more of the chassis because the combiner that goes to the back that each of these frames plugs into is also modular and scalable. So it kind of starts and it stacks up in sections. So there's not a totally separate combiner for, say, 4 of these drawers versus 5 or 6. You're adding another section and it kind of stacks all the way up to the output at the top. Or conversely, you think of the output connector as the starting point and you stack sections on the back. So yes, you don't have to throw out pieces. It's not just look, because everybody's modular transmitter, you can pull a module out of a 10 kilowatt and put it in a 20. But 98% of the rest of the transmitter is different. It's a different frame, a different box, a different control system. In this case, it's all really the same. It's just how you set the software to go control it. So yeah, that's exactly the idea. Did that help answer your question a little bit?
Then I know you. Go ahead.
I'm sorry, go ahead.
Relating to that, in terms of reliability, suppose you have 5 slots there, is it?
Yeah, yes.
Suppose your power is covered by 4 slots. Could you have just like an idle or standby module in the 5th one? And if one of the other 4 fail, then it would automatically change over to the 5th.
Yeah, so that's a good question. So there's 2 ways that works. So it's some very low powers. We can actually do N+1 switching in this same rack. So since each module is a kilowatt, let's say you wanted to have a backup, right? Well, you could have an exciter controller, you could have 2 or 3 modules where you could actually do physical switching. The other way is, to your point, if I didn't need quite as much power, each of the 4 run, but they run at a much lower power level. And then if one fails, it turns the other 3 up to get to your power that you need. And it can do that across multiple frames in the same way. Because sometimes the switching makes sense when you need to switch the entire frame. But here's kind of what you were talking about is, I may not need all of the power, so I really have the equivalent of an extra module in reserve. Now, it's not like there's a patch panel back there and I'm moving cables around. It's really a case of I'm spreading the load across all the modules, and I can still maintain the power if one of them's failed because I've got a bit more headroom. And then you can go pull the failed module out and swap it out, or put it in a FedEx box and send it back for repair. If you do your own bench repairs, you take it to the bench. But again, the point on the repair that's kind of important is both the power supply and the amplifier and the controller are all in the module. So, we've all probably had things where you pull a module out of a transmitter, frankly, including ones we've designed before and many of the others. Well, it's kind of useless because you don't have a power supply to turn it on, you don't have the controller to turn on, and you don't have any cooling. So then you kind of build this little fixture with fans and a power supply, and you try to fake out the controller. In this case, all of that's in there. So you can put primary power, 240 volts or 220 volts going into each module, and the control and the turn on and the cooling and everything's in there. So it's much easier to do repairs because it's almost like all the systems in the transmitter live in the module. They're not tacked on a back wall or fans on the back door. They're all in each module. So here's a little bit of, yeah, go ahead.
I'm
Bud.
sorry. So that would have like 4 connectors, let's say it's a 1 kilo box that you're buying, right? And that would be the exciter, controller, and one module?
Yeah.
Or, yes?
Yeah, unless you wanted redundancy. And then there is an option if you wanted to have two amplifiers, you could do it two ways. You could do it with a switch where you switch the amplifiers. Well, that has a bit of an interruption because you've got a physical travel of a switch. Or you could kind of size it as a 2 amplifier. And then if you lost something in it, the other one makes up the difference.
So then it wouldn't, so then that combiner on that back plate, would that only have like 2 ports on it?
Yeah, good point. So,
And then what happens if you grow it to like from a 2 module up to a 4?
Yeah, so in this frame, the purple kind of color here that has the blue 4 modules, there's a stamped out piece of metal that's the combiner inside. So, you could either change the piece inside, or probably the easier thing would be to change section 4. We just get a different combine, do an exchange, but the parts are the same. But there's a reject load for each port on the combiner that's on the heat sink. So the little slanted thing below the yellow is the heat sink. And then up to 5 inputs are on it with a single output on the back. So, there is something to change, but it can be either done at a kind of block level, if you will, or a module level, Bud, or you could change the piece inside, which is the combiner. Frankly, it's probably a bit easier to just change, we do an exchange on the assembly number 4.
And what's the output? Is there a picture of the output?
Yeah, I should be able to get to that.
As you can tell, I'm very interested in this product.
Well, you're reciting all the questions I sent you, so thank you.
I haven't checked email since about 2.
Sorry, I was being a smart. Yeah, so it's generally a 7/8 inch unflanged connector on the back. So I think I've got another picture of that a bit forward. This is the combiner. So while I was saying it comes in sections, you can see it in a rack on the left. So the little fans, those are for the reject loads for each drawer. And then you can see in the bottom right, that's showing you the blind mate EIA connectors that the whole frame plugs into. So you can kind of see by the shininess, it's a machined aluminum. And in the right, this is where the output connector goes at the top. And so these come in 2 port blocks, and they all kind of stack up in series away from the output, which is at the very top. And in the middle picture, it's kind of a sandwich. So the longer piece with the connectors on the left-hand side is actually the combiner, and the piece on the right-hand side is actually the splitter. So, you have to take the drive, split it, get it into each module, and then the outputs all need to go into the combiner that each has a reject load per port that goes to the output. This is a little bit about how those plug together in the combiner ports.
And on the combiner ports, you're saying that you can add that in the field going downward position?
Yeah, so this top piece here in the bottom picture that's got the spot for the EIA flange at the top, it's kind of hard to see, but there's you can slightly see little marks. These are kind of module pieces that you keep stacking together that build from the top away that add more combiner and splitter pieces. So, you could have a 2-way combiner, Bud, and you could go to a 4 or, a 6 or whatever, and add to the pieces you already had.
Interesting.
A standard mid-Atlantic rack, or?
Oh, yeah, I don't know that it's specifically mid-Atlantic, but yeah, it's a standard 19-inch rack. So they go in good question. It's a little bit deeper. So I think they are like 36 inches deep or so. But it's a standard 19-inch rack.
For ventilation purposes, you'd probably want a dedicated one, but theoretically, if you didn't have as many,
Yeah, you could put other stuff in it. So like, you know, if you had a 10 kilowatt transmitter, which would be 2 rows, you have plenty of room to have, you know, if you have an STL or you have something else. And generally, while you can't quite see it here at the top, there's a spot for a cabinet flushing fan. So there's a fairly large fan that helps, you know, flush air through the box as well. But the cooling of the modules and the PAs is actually done all in each module.
Are you able to buy the transmitter pieces without the rack if you wanted a true middle Atlantic? That looks like
Yeah.
a stocking rack.
Yeah. Yeah. So generally what we found is at the lower power levels, guys don't want racks because they have some place they want to put them. At the higher power levels, it's a little more unwieldy to ship it in pieces, right? But as long as the rack was the proper size, Bud, it could go in it, a standard rack. So I think in practical terms, probably I would say once you get to 20 kilowatts, which is 4 sets of these frames, that's probably as big as you would want to go put in your own rack, just from the standpoint of shipping it and so forth, because the combiner is bolted together and tested all as one. And so it'd be a little bit harder to ship all that stuff if you were trying to put it in a rack at the transmitter site.
Right.
But, you know, if you had a specific type of rack, you know, we could integrate it into that at the factory. So if you had a row of racks that you wanted it to match, you know, as long as it was the right size, we could do that. It's not a custom cabinet, it's a standard rack. And this just kind of shows, I was mentioning these configurations, you know, most of them in a single transmitter mode are like the picture at the top, you know, 4 modules and a controller. But for example, you know, the middle one shows 2 1 kilowatt transmitters in the same rack. So like, you know, if I had some translators where I've got multiples at the same site and space was a concern, I could still have modularity in a pretty compact footprint. And then the one in the bottom, you know, I could have, this is saying 1 + 1 and n + 1, but you know, they're switching, so you could switch different amplifiers to the different controller. And remember, the controller has dual exciters in it anyway. So, you know, frankly, those kind of configurations tend to be more popular in places in the world where one company runs a whole bunch of radio stations, like, you know, somebody who runs all the BBC radio stations where they got BBC 1, 2, 3, 4, 5, 6. You might want to have something like this. In the US, it's a little less common because we don't have as many consolidated sites and everybody running about the same power. Our network planning is a little bit different, but the capability's there. I'll skip over that. There's some control. So anyway, that's kind of a high level on the transmitter. I'm happy to go back and dig into anything specific that you guys, you know, want to have more questions on.
Are parts proprietary or, you know, replacement parts for the modules, things like the box fans and things like that?
No, they're generally off the shelf stuff. So the RF devices you can buy from anyone, you know, so things like the actual circuit boards, okay, it's a circuit board made for that design, but the components are off the shelf. Now in the switch mode power supply, there are a couple of coils that are specifically made, but generally all the subcomponents, I mean, you can buy most of it at DigiKey. So, you know, where our intention is to make it easier to repair, in part because we kind of have 2 paths. One is if you don't have people who are technically inclined to do that locally, we want to make everything modular and easy to put in a box. So it's not this huge thing you're trying to send, so that it was easy. In fact, the objective was, I want it so it can go in a FedEx box and you can send it anywhere in a day or 2 in the world. And that it doesn't have to be someone technically competent to grab the module. But like I was saying about how the power supply and the RF amplifier and the control and everything's in the one module, the other side of that is in some parts of the world with tariffs and duties and so forth, it's really hard to ship things into the country. You have to have special permits. And so the idea was to make it as standard as possible so it was easy to repair. So For sure, there'll be some machine part, like, you know, the heat sink that comes on the side of the power supply. Yeah, it's specifically made for that because it fits in a specific size, but it's not like we have some, you know, special silicon or a chip that's, we only buy for us. It's generally off the shelf stuff.
And there's like good stock in Quincy and that have to go.
Yeah, so one of the things we've been doing since the product launched is building up two supply chains, one here in the US that we manufacture in Quincy and one in Europe. You know, the first units will be coming from the Europe office because that's where we did more of the development to start. But they come to Quincy, and like all the things that we do there, they come in, we put them on your frequency, we test them, and we have full repair capabilities. But for example, we've got built up the first switch mode power supply in Quincy, and then we'll do the amplifier and so forth. The metals from a metal shop in Quincy that, you know, that makes it. So it's kind of, you know, designed for the globe and then manufacture in the hemisphere that makes the most sense.
So what,
Yeah.
where are you at as far as delivery at this point? This was shown at NAB.
Yeah.
So we're, you know,
So
10 months
we've
in.
delivered some units,
Mhm.
both in Europe and here in the US. We started at the low powers, about 5 kilowatts. So we've probably got, in the US, we have somewhere around 50 transmitters that have been ordered of power levels from a couple of kilowatts up to 35 kilowatts slated for delivery throughout the year. You know, just being transparent, the global, you know, parts challenge and the supply chains making it go a little bit slower than we had hoped. But it's generally not a development issue. It's more just, you know, lead times that had been 16 or 20 weeks are, you know, 52 weeks on devices or greater. But, you know, that's kind of the same for almost anything. I mean, the car guys have been fighting that for years now. And so I would say, Bud, you know, probably the best way to typify it is, you know, we've got strong orders. We made some shipments at the lower power levels. And, you know, we're working with everybody on delivery times because of the supply chain challenges. So, you know, look, if you've got a schedule or anyone has a schedule and we think we're going to jeopardize it, you know, we'll be upfront and say, hey, look, we probably can't make it with this. And either we can make it with another product or, you know, as much as it pains us, you know, maybe there's someone else you need to work with on this particular project because we you know, we want to be transparent about it. But that's kind of where we're at, Bud.
Thank
So,
you.
you know, we can go over the specific. Yeah, so it's designed, it's standard HTML5 interfaces, and it's SNMP v3 interface if you want to use SNMP for an interface.
Yeah, suppose you want to make a test lab for testing consumer receivers. You don't need a whole high power thing. Could you use just the exciter block for a low power and for whatever function you want to testing?
Yeah, for sure. So whether you use that or, you know, we have other exciters that, you know, if you need really low power, we have a version that's like 100 milliwatt output. But then there's like a 60 watt and a 500 watt version.
Yeah.
So, but yes, you could just take the end module block, and I think it's 5 watts out of that is what the driver is. So yeah, if it was some sort of a lab test where you don't need much power, yeah.
Is AM HD radio available?
On this one, right now we're delivering FM. So HD radio is available with this. And on AM, while our transmitters are capable of HD radio, we don't offer an HD radio exciter at this point. So, you know, the demand's been fairly low on those, but all the BEAM transmitters are capable. I would expect in the next, you know, 12 to 24 months, you'll see something from us on that. But there are some guys that do want to do all HD, and we do have some work we're doing there.
Is it
Rich, has anybody,
It's FMHD?
No, so but there was a question here. I'll just repeat for the guys on the line: is it a different module if it's FMHD? So no, they're multi-mode modules, so the bias gets changed. So you can buy the transmitter. Look, if you're smaller market or you go HD's never my future, we sell an analog version. We also sell a version that can run HD. The components are the same. It's more of a software capability, but in a module, I can plug one to the other. So it's not, our intention was to make servicing easy because you may have 5 or 6 transmitters, some that are analog, some that are HD, and we wanted to keep the module the same because it's just easier for everyone to service. It just runs in a more linear mode and it's biased differently for HD FM.
Have any shipped yet? Doing HD?
No, so the first shipments have been all analog on this. We do have some HDs on order, but the customer that asked for those, one of them actually placed orders with like delivery staged over about 12 months. So I think, Bud, probably by, Q2 is probably, I think when we, end of Q2, so that's like June or beginning of Q3, July is when the HD shipments probably happen based on what the customer wanted.
One final question, Rich.
Well, I don't know if it'll be final, but I'll be glad to answer another question.
Using this in an HD only mode, how derated would the power be?
Oh, just digital only?
Yes?
Yeah, generally, it's about 30% of peak power. So I don't remember off the top of my head in HD only, but it's usually, so like, in general rule of thumb is if I've got a 10 kilowatt transmitter, I get around 3 kilowatts of HD only out of it.
Okay.
Now the caveat a little bit is it has to depend how much peak clipping you do on the OFDM waveforms and how much correction you get. But generally with the peak to average ratio, it makes it about a third.
Okay.
And so the thing that's a little, so here's a point is, you can go look across every stuff we make, stuff other people make, something that everyone says, well, that's a 10 kilowatt transmitter. You find, well, some 10 kilowatt transmitters do 10 kilowatts and some really do like 14 or 15 kilowatts. Now, they may not always be rated for that in analog, but where you see the benefit is, it looks like there's less of a back off for HD radio. The physics really are, it's the peak capability of the RF devices, how much you can cool in the power supply. So when you count up all the devices in a transmitter, there may be enough peak capability for 14 kilowatts, but because of cooling and being a bit more conservative and so forth, in the US, we'll size those as a 10 kilowatt transmitter. And then you go, oh, well, geez, I can run a bit more HD power on this. Well, there's no magic. It's just that there was more headroom with it to begin with. Right. So there's just a comment on peak capability.
What kind of inputs are available on this kind of device? Is it just, XLR or BNC or?
Yeah, so there's a mix on the back. Right now, it takes in analog on an XLR, AES, and then it takes in baseband composite. Now, in the controller and the exciter, we've got some roadmap items to look at micro MPX as an option to come in with Ethernet, if that's a transport mechanism people want to use, as well as some of the other IP standards. So there's some standards that the codec manufacturers use for codec interoperability. So we've taken a look at, do we embed a codec in there or not? Everybody kind of has their flavor. So one of the things is, for sure, there's no technical reason why we can't put more capabilities into the transmitter. A lot of time, which if you've got a very simple repeater site or a very simple transmitter site, it's great. If you try to integrate into an existing site, I mean, you guys all know this, usually, unless there's a fire or you're moving, you don't replace everything in a transmitter site, right? The main transmitter becomes the backup. The old processor becomes the backup. And so you kind of have to have some switching between these things, and you find whatever the common form of interface is, which kind of is almost always the last generation interface because you're reusing older gear. So, so the short answer is we've used all the standard interfaces today. We've got footprint in there to be able to do things like micro MPX or audio over IP or some of these other things. We're just not sure which formats to pick right yet, because most people have other things in their plant that they use before you ever get there. If you're a Wheatstone plant and you like Wheatstone audio processors, we'd say, oh, we should have a WheatNet. If you're Axia guys, well, then you'd want to have Livewire. And I guess if you're SAS guys, you'd have Dante. So everybody's, it's a little bit hard to decide what the spigot is. So we picked the standard ones for right now.
Three phase, can it take three phase in?
Yeah, so there's two ways we do that. So generally, on these, every module is a single phase power supply, and the power distribution, we just select the wiring to make it three phase. So if you were a 1 kilowatt transmitter, the answer is no, it really wouldn't be practical because there's just one power supply. But any of the transmitters of size can either be single or three phase. We do have an option, although it's not in the first module, is actually having a three phase version within the module. And this is something that the European guys ask for a little bit more because they do want to run three phase, like on a 1 kilowatt. In North America, generally, you don't mess with three phase until you get to maybe 5 kilowatts. But the point is, the AC power distribution that comes from each of these frames to a common point just gets strapped differently for three phase or single phase. Did that answer? Okay. Yep.
So currently I know it's FM and FM plus HT. Is there any road mapping for potential AM?
Yeah. So we have, well, we haven't announced it publicly. We have development for some improvements in AM, and one's a next generation high power AM transmitter that uses pulse step modulation. So not PDM. And it has a similar modular architecture as this and some of the capabilities. Now, to be clear, sometimes, and even my colleagues go, oh, so I could like take an FM transmitter and plug in AM modules. Well, no, not really, because, the coils are really big to have an AM output network, and they're really small for an FM network. But the architecture of, I have split separate modules that are easily hot pluggable and control architecture the same. There's a bunch of similarities there, but when we go from FM to VHF TV and VHF TV to UHF TV, the architecture is virtually identical because in the same footprint, you can change those combiners we were looking at and make them for high band VHF channel 7 through 13 or UHF, because FM is the most difficult in that footprint because it's the biggest size, right? So going to VHF, UHF, the architecture is virtually identical and the modules are the same because all the RF devices for VHF and UHF use 50 and 60 volt power supplies like we use here. And the wavelength is such that we can put all the combiners in the same footprint. And the cooling and the RF devices all match up pretty closely. For AM, it's a similar architecture where it's modular and there's small modules of about that size. But because of the coils at those frequencies, it's about 50 kilowatts in a single rack as well, but it's not exactly the same. So, but yes, there are commonalities.
One question pertaining to the FM and the VHF and UHF units. What would it take to change the frequencies if for some reason there's a need to, for, I guess, various reasons or for sale or anything else?
Well, so generally the combiners, so the constraints usually are harmonics. If you think about it, the low pass filter for channel 2 is going to lop off everything, in the FM and the VHF TV band. Same thing in FM, because I have to have low pass filters to get rid of those harmonics. I couldn't just change the tuning, on the device or punch in a different frequency and get it to jump, to channel 7, even if power supplies really are the same and the devices are the same. So practically what happens is the frequency band determines that you have to change a couple of these things in the combiners and the low pass filters. So there's a lot of commonality in parts, and in the exciter, because you're coming out at like 100 milliwatts on frequency, you can go from channel 2, VHF to, I guess you can actually go to channel 69 in UHF, but nobody really operates it anymore. So at those power levels, the exciter can be broadband where it could change all of them, but the limitation ends up being low pass filters and combining need to be in a couple of chunks. And so in our case, they're in FM, they're in VHF, and then they're in UHF. So while there are some bits that you could move, it would be impractical to take a FM transmitter on 99.5 and move it to channel 7 TV.
Oh, that would not be too practical due to loss of power
Yeah, yeah,
and
there's
other issues. But for the FM side,
oh, you can move it
if
to any
you came from
channel.
one
Oh,
channel to
I'm sorry, I
another-
misunderstood. Yeah, so sorry, I think I understand your question.
Okay.
So yeah, I was thinking you were thinking of FM to VHF. If I have an FM transmitter, it's just punching in the frequency on the controller. You can go to any point in the FM band. There's no tuned, it's broadband. Same with, I can go from channel 7 to 13 in VHF as a frequency change, and I can go from channel 14 to what, channel 36 in the US, right at the
68,
top
I
of the
think, is
band.
the highest.
Well, yeah, spectrum wise, they've changed and moved all that down. Like in the US, it stops at about 36, right? Because of repack. So the UHF band has gotten a lot smaller in TV here, and the same in Europe. They've reduced down. So as long as it's within the band that's authorized now, it is indeed broadband as UHF or VHF or FM. So yeah, in that case, you bought a transmitter for 99.5 in Philly, and for some reason you need to pick it up and move it to another town and put it on 92.5. You just punch it in the front panel.
It's amazing. It's just
Yeah, it's a lot easier than tuned circuits for sure. So,
far cry from the old days where you had to.
there's a little bit less fluby dust and smoke and mirrors inside. Yeah.
Didn't see any mention of DAB plus.
Oh, yeah. So, because I kind of focused on FM, I didn't, but our exciters have DAB and DAB plus operates inside, and the VHF versions of this will operate on what in the rest of the world they call band 3, which is channel 7 through 13 here. And DAB, for those that don't know, you take a TV channel, an 8 megahertz in Europe TV channel, and you break it into 4 DAB multiplexes. So channel 10 could have channel 10A, channel 10B, C, and D, and you get about 2 megabits of data through about 1.5 megahertz of RF. So yes, it does do that, the VHF version, and the modulator has DAB, and there's a thing called a head end, DAB head end, which is analogous to the importer exporter in HD radio. But instead of just having maybe 3 or 4 channels, you run AAC plus, and because there's more bandwidth, you could have 24 or 30 channels running through this wideband transmitter. TRE, the radio experience, is a platform BE's had for a long time, which basically took data from your playout system, other data that you might have, and allowed you to display it on HD radio and RDS. It was an application that lived at the station. It was a bit static. It had a hosted option called Message Manager. And you could put advertisement or other things on the spots. We started at NAB working with a fairly large radio group here in the US who had been using TRE but wanted it to do a little bit more. And we worked with some other broadcasters as well to get some inputs to try to get something a little bit more updated. But so the real key is, look, more and more people are having big screens in their car that can display a lot. Some by the government mandates to have backup cameras and so forth. And others just as screens become bigger and bigger. Visual content becomes more dominant in cars. About 80% of cars today can display some sort of visual content, whether it's just RDS and it's more text-based, like in the upper right-hand corner, or it could be with HD radio in the picture to the right. But more and more cars have the ability to display this, and people can see it. In a blog recently, the guys at Westwood One talked about some of the research they had done, and it was really interesting. They said nearly 70% of regular radio users, guys who listen all the time, pay attention to the content that's on the radio. They're looking to learn about it, and about 2/3 of them have recall of this as it relates to the ads. So if I saw an ad for, Bob's Hamburgers, it's a pretty big recall percentage. And then out of those that recalled it, about 85% said they planned to visit the retailer. So, a lot of times when we talk about technology, it rarely connects to the revenue side of the businesses we're in and the stations. This is one that really ties to the advertising side, pretty well. So that's kind of the why. The how is a bit more around, you have all these places data can come from. The playout system, anyone's automation system. You could take weather from NOAA. There could be sports feeds. You got real-time messages someone could type in from the studio. You could have things from, emergency alerts. There's advertising messages as well as, metadata lookups like album art. And there are all these places you can send it: RDS, HD radio, DAB. You can have like radio DNS. You can have it for streaming. So the radio experience TRE Plus is kind of like this traffic cop in the middle that allows you to take all of these and package it up in a meaningful method. Because sometimes, if you just stream out of the playout system, it might have "don't use this cut" shows up in the title. It may have things that are in all caps, but you want to get it cleaned up. It sometimes you have internal messages that you really wouldn't want to display. So TRE Plus is a platform that we developed that is hosted. So it's in a hosted on it's either on AWS or Microsoft Azure. I don't remember which platform. It's on Azure. Thanks, Joe. But so you can create a specific message, what time of the day you want it to run, what you want it to say. You can have different versions in RDS versus HD or the dynamic crawl, and you can verify what that looks like. You can then tailor these messages to go across different radio stations and different times of the day. But you can also keep track. So if you go, well, okay, maybe I did sell something to an advertiser. This is a little bit like having an automation system and a scheduling system for the radio text. Now, sometimes you just want it to be things that promote your station. Other times it might be something that you want that's got a commercial aspect to it. But the exciting thing is I don't need to be a commercial station to use this, because generally, and we validated this with our Washington attorneys, the FCC attorney, is that as long as you follow the same rules for underwriting, not specific calls to action, and all the same things you're doing, you can acknowledge underwriting via the radio text displays in HD. And in fact, if you look at what most of the commercial guys are doing, it's actually more similar to an underwriting announcement, because you're usually giving the name of the business, a website, and some acknowledgement. It's not like saying, go down and buy Pepsi for $2.99. It's acknowledging someone. In many cases, they're professional businesses. So the interface is pretty easy. I can have multiple stations all running through the cloud. I can do groups and so if I want to regionally things, but if I own a number of stations, I want to go everybody in the New York city cluster. If I go, I want to look in the Northeast region, or if I want to say all the rock stations across a group, it's got the capability to do those things. And the exciting part is it really allows you to make some money with this. Anyway, you can schedule what time of day that they run in, and which duration that they might cover, and days of the week and so forth. So if you're selling it by drive time, you can do that. There's also the ability to do cover art, and we use cover art in kind of a general term, because this could be associated with the songs coming from your playout system, but they could also be the logo of your morning show. Of course, you can put in station logos, but it might also be a piece of artwork associated with an advertiser. And so if you go back to that point of there's higher recall when people have a visual message that goes along with the audio message, whether you're doing non-com and you're acknowledging, XYZ law firm for underwriting the station, you can have their logo there. If you're doing, Home Depot ads, and you might want to have their logo there. So it allows you to do those things. Yeah.
One of the biggest problems that people have generally realized with EAS is you send it out, goes to everybody. But the Common Alert Protocol provides for delivery to, for instance, polygons on a map, or to jurisdiction, or category of recipient, or something. So that's what you're talking about here in terms of your content for the underwriters or whoever else. It's very much similar to that problem with the AS. And it is possible to do it with the AS to deliver separately. Certainly with ATSC3, it's already built into the spec,
Right.
but it's not really provided that well when it comes to radio, because you might, for instance, say you're doing an ad for a certain car manufacturer, but then you want to be able to say, but you're over somewhere in Jersey. Here's the address, etc., for the dealer over there. But over in Connecticut, you can have a different address and phone number and website and all that. So you'd want to be able to do that. And it's very much the same problem as this selective delivery.
Yeah, it certainly is. So we can do multiple different streams associated with the same audio content that can be regionalized. The limitation is in broadcast analog or broadcast HD radio, there's not really geolocational tags that the receiver knows where it's at, that it picks off different content.
You have to have the navigation data into the receiver.
Yeah, there's different, exactly. There's other methods that people have proposed with single frequency networks that are an emotive topic. But generally in radio, we don't have that level of targeting based on where the user's at today. It would have to have a side channel. And that's where, things like hybrid radio, which this can also feed, gives you the ability to do some of those things that we can't do with a standard broadcast.
Flash in there.
Yeah, I think it was just going to sleep. So one of the other things that we've done here is provided a thing called Content Watchdog, where we actually can use an off-air receiver and then actually tie it back to what we've said is going out for the data to make sure that it really made it through the system. So we can use like an Innovonics receiver or an SDR. It can listen and it will compare. I sent out that said, WXYZ is the best radio station, and I can see coming back in, WXYZ is the best radio station. Maybe it's not so interesting when you got to match up that the Beach Boys went out and it said it was the Beach Boys. But for example, if you had an advertising or underwriting message, being able to validate and have a closed loop is pretty helpful. So that's one of the things that we've added, which is kind of keen. And to give you an idea, this is really where the payoff is looking at what's on the screen. If you drive around and you see a display like the one in the upper right, and it's just got the frequency, which is fine until you start seeing people like the RDS implementation here, where you get, the station call letters, you get a format, you get artist and title information. Also, you may see it with station branding. So I have something that might be during stop sets or while my announcers are talking. In this case, the WTOP, I'm talking about news, traffic, and weather and other things. Or the place where a number of stations are making money is with the advertising option. And in this case, the most common impact is they're selling an advertiser. Many times it's an attorney or other professional business. And when you're running normal commercials, you have different text of the business that's covering it. So you can also do that where you weave it in with the song, artist, and title information if you want to, but that's the most common. And like I mentioned, the thing that's been interesting, the practical application have been attorneys and doctors and insurance companies and so forth. And because, like if you think about that, saying who it is in the website isn't precluded in non-commercial because there's not a call for action. It generally follows those rules.
Maybe somebody remembers. I do recall seeing a SBE meeting from New York City back in, what was it, August or something? And there was some discussion about either it was
Auto stage.
Hmm?
When you mean auto
That was
stage.
November Auto Stage.
Auto
Yeah.
stage. Oh, is that a different system from TRS?
Yeah, so AutoStage is a delivery platform, and it allows you, and anyone else jump in, dial me when I get in the weeds, but basically think of it as hybrid radio. It's allowing you to have other content that gets delivered to the car that's not necessarily going over the air. So it's a delivery mechanism. It has to have some middleware in the car, and it generally has IP delivery to those. But what this is it's basically, think about it, it's an automation system for your text. If you think that whatever automation system you're running, Audio Vault, RCS, whatever you're running, right, that's how you put together your audio content, organize it, and play it out over the air. This really is doing that for the metadata, and it allows you to either take information from the audio content, make sure it's in the proper format, and then add these other things like for HD radio, the graphics and so forth, or add advertising messages. So it's kind of the best way to think about it is it's kind of like a metadata playout system, and it can point to RDS or HD radio or things like Auto Stage or Radio DNS or whatever your streaming app is. So it really doesn't matter what the delivery mechanism is. It's more of a data management platform.
Is I'm assuming this ports out to your RDS encoder at the transmitter?
Yeah.
Is that just a common, interface into it, or a common stream? Data stream into it?
Yeah. So, whatever, everybody's RDS thing has a little bit different interface and we plug into them. But yes, it's the most common thing is I'm running analog FM. I go into the RDS generator. This allows you to match up with your playout system to know when I'm in commercials or announcement, when I'm in news. So one of the things that we're rolling out is for the guys that are associated with NPR is to be able to take data from Metapub for the different news and so forth, and be able to bring that out and put it on the radio. Sorry, I'm trying to also be cautious of everybody's time. So
RDS, that's strictly an analog system, but on HD radio, it's a similar kind of function, right?
yeah, it's the PAD, the program associated data that plays out. So, here in PAD, you can look at it. It looks ostensibly the same. It may display with longer wraps, and then you can add graphics or generically called album art, but it doesn't have to be just with the music. It can be other things.
And it can be set up to go to whatever destinations you need. So if it's just RDS and a radio, or you have the HD display, website, billboard on the side of the road. So whatever destination you have, we can massage the data to fit.
So, and this is the last one. Here's kind of the takeaway. And look, as engineers, it's not often like we were talking about budgeting earlier and how we go justify things, right? Most of the time we're always saying, I want to spend money, and somebody goes, why? This is kind of neat in that you're actually showing up saying, well, yeah, I want to get a small monthly subscription, but you can actually go make real money with this, Mr. General Manager. So some of our customers, we've got guys not in New York, but in a, middle market in the Midwest, they've got a cluster of 5 stations, and they went out and sold these for, around $4 or $5 grand a month per station. And it comes up, and every time there's commercials, it says, that one I think said one of theirs is a real estate guy and one's an attorney, but it shows up and it says, go visit these, car dealership or whatever. These guys out of their cluster are doing about 300 grand annually in new revenue. But even in small, we've got a small market, top 200 market on the West Coast. They added it, and once they realized they could sell it, they did about 45 grand a year. So, you go to an advertiser, usually it's a year-long contract. You tell them, pay me a few $1,000s a month or whatever it is, depending on your market size. And you say, every time, if you're commercial, you go, every time I'm running the spots, we'll cover the commercials. Where before we were covering them and just saying WXYZ, now we'll say, such and such attorney at law, and put your website up. And you make it part of their advertising campaign beyond just buying spots. And if you're non-com, you could have underwriters covered, there, perhaps when you're doing news or whatever. So anyway, that's the thing that gets kind of interesting is you actually can have a discussion with the management team about, hey, there's this technology that, there's a small cost, it depending on how big your solution is, it's under $100 a month. And you can go sell it and make some money. So not only do you have a little bit better environment for your listeners, you can actually go make some money with it. So anyway, that's the thing that why I wanted to mention this is while we did talk about transmitters and FM transmitters, so it was very specific. This is the kind of thing as really radio becomes more of I care less about what you're listening on. I want to be on everybody's platform. This is designed to talk to whatever platform that you want to deliver content on, because almost everything has a screen now that our listeners are listening on, and they're expecting some visual content. And we've got to be able to be there to compete with our competitors who might be streaming and they already have a bunch of it, or a podcast, and there's already a bunch of content on there. And the thing that ends up happening is, when you think about that, if I'm the guy in the upper right-hand box, I kind of look like I'm out of touch, because everything else our customers and our listeners listen to has a lot more information on the screen. And so it's almost like you become noticed because you seem not the same as everything else, because you're missing all this data that they've come to really appreciate. So anyway, that's all I had. I think I've got something that says thank you, but I can say thank you anyway. Look, we really appreciate coming, Jeff and everyone who's dialed in on
Introduce Joe.
Skype. I will introduce Joe Myers. So for those who didn't see him, you're pretty good with a microphone, Joe. Joe has rejoined BE, and he's our Eastern Regional Sales Manager. And you know how to use a mic? I think you know something about that. I'll let him take you through the rest of it.
Well, I just want to say thank you guys. We certainly appreciate it. And if there's anything that we can do, any questions, need information, quotes, that kind of stuff, we're happy to provide it for you. So thank you for opening your doors. Thank you guys for hanging out and online listening to us. We appreciate your time.
Thanks for joining us. Please remember to subscribe to SBE 15 New York City.